Hey there, my name is Alejandro, and welcome back for day 182 of me doing Daily LeetCode challenge as I reach 1 year's worth of great contributions here on GitHub. So today's promo is for January 14, 2025, and without further ado, let's get straight into it. Okay, today we get a LeetCode medium from 2657, find the prefix common array of two arrays. You're given two zero-indexed integer array permutations A and B of length n. A prefix common array of A and B is an array C such that C of I is equal to the count of numbers that are present at or before the index I in both A and B. Okay, return the prefix common array of A and B. Okay, a sequence of n integers is called a permutation if it contains all integers from 1 to n exactly once. Okay, I have no idea what this means, but I see the word prefix 10,000 times. So I'm going to guess this is something with prefix sums. Okay, example 1. A is equal to 1, 3, 2, 4, 3, 1, 2, 4, 0, 2, 3, 4. Okay, at I equals 0, there is no common number. So C of 0 is equal to 0. At I equals 1, 1 and 3 are common in A. What are the digit values? They can be from, they're from 1 to 50. So if anything, I can do from 1 to 50 in a hash map. Okay. Yeah. One and 3 are common, so yeah, so if anything, what I want is res is equal to an array, set A is equal to, but doing the intersection every time might be annoying, right? But essentially this would be my solution. Set equals set. And then for I in range length of, let's say, A, right, assert that length of A is equal to length of B. Then essentially, res set A dot add A of I, set B dot add B of I, and then res dot append the length of set A dot intersection set B, and then return res, right? Does something like this work? Okay, it does. Let's submit. And there we go. Completion streak 182 days. Consistency is key. See ya tomorrow. Okay, nice. Low. So obviously, okay, so yeah, we might be a little bit slow just because it's like, okay, so it's weird, right? Just because there's only up to 50 integers, this is going to be like, pretty fast because I'm doing an intersection of at most 50 elements at a time. But yeah, there's probably a faster way of doing things, right? But the only other faster way I could think of is like, maybe it's like, you do the dictionary, but then it's the same problem if you end up like, making copies of it all the time. Maybe here it's like I could do, this is 0 times 51. 0 times 51, right? And then I just do a RA frex B frex A here we'll do frex of A of I plus or equal to 1. Frex of A of I of B of frex of B of I. We can even do equals to true, right? True. And here we'll say false, false. Or if anything, we could have like, the lowest, the earliest integer for each, right? Something like that, yeah. And then like, well, here we'll just do, there's that append of Prefix of A of something like that might work as well. Yes, something like that works as well. It's just maybe a bit more confusing code to understand, but it's the same idea. Actually, this makes my life slower. Okay, so we won't do things this way. Yeah, because here I'm abusing the fact that n is up to 51 and so on. So yeah, so this is my original solution, which I believe makes perfect sense. Yeah. So yeah, so this is 11 ms. Here we can get rid of that just to make things a little bit faster. Here we can do res, comma set a, comma set b is equal to this set and set, right? Submit something like this. Yeah, so we're at 11 ms. If anything, I can even do equals this. Maybe this is even faster, or it might be slower. We'll see. Seems like we're just as fast, right? We've kind of hit the max that we can get. Or maybe if we submit one more time, maybe we get a different thing, whether we're slower or faster. We'll just give it one more shot. Yeah, we seem to be a bit faster. So here, if anything, we'll just make it an empty array, and all the time we're just gonna do dot append this length, right? And now submit this again. And okay, now with the little spacey space. Okay, but we seem to at least be close to the standard deviation. Just that, like, yeah, okay, 40%, 57%, and so on. I wonder if there's a little bit of a better way to do this, right? When B is an array C, such as C of I is equal to the count of numbers that are present at or before. Yeah, if anything, I could have a current count, right? A comma B is equal to A of I, B of I. Not in set A. Set B, cur count plus or equal to B in set A, set B dot add. Count, continue. Does something like this work? It does indeed, right? So maybe something like that might be a little bit faster. Let's see, now we have a cur count, and that way we don't have to do set intersection every single time, right? Right, so there we go. Maybe this is how we make it faster. Yeah, there you go, 5 ms and so on. And okay, that way we don't have to rely on set intersection every single time. So yeah, it makes sense. It's like, if you're about to add something to set A for the very first time, then like, okay, check if it's already in B. And so, okay, yeah, this is definitely going to be There we go. Okay, so this is a much better solution. Seems like we're like more in the optimal range. There we go. Bada bing, bada boom. That's exactly what we like to see. So as always in my videos, I do a quick recap if I was able to solve the problem. So this one, essentially, what you want is to build an array C where C at index I represents you're given two integer arrays A and B of length n. And so what we want C of I to be is essentially the number of numbers that A and B share in common up to index I, right? For example, at index 0, here A has a 1 and a 3, so there's no numbers in common. At index 1, here there was 1 and 3 in A, as well as 3 and 1 in B. So there's two total numbers they share together, the 1s and the 3s, right? And so here you'll see 0 here, 2 here, and etc., 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 right? And essentially the way that I built this algorithm, essentially I have my resulting array, right? So obviously like, you know, the array C that I want to return. And here what I'll say is I'll have a set of all the numbers A that I've seen so far and a set of all the numbers B that I've seen so far up to a certain index, right? And here I'll always have a current count of the number of numbers that A and B have in common up to a certain index I, right? So here I'm going to say for I in range length A, because length of A and B are the same, they're both of, you know, size n. Here I'm going to say, okay, let's grab the numbers A and B, which are at index A of I and B of I, right? Because we're doing for I in range length of A, right? Here we could even probably do something like A comma B in zip A comma B. I wonder if something like this works. Could I do something like that? Yeah, so I could do something like this. Maybe this is a little bit faster. Essentially, it does the exact same thing. But yeah, and there we go. We get to 2ms beats 95.83%, right? So there you go. And then we can just say like, okay, if, you know, then we have essentially, basically we're going to go through every single index I and essentially ask ourselves like, okay, we're going to grab the number that's at A and grab the number that's at B, right? If A is not a number that we've seen so far, then, okay, this is very interesting, right? Because it could have been that we've never seen this number so far in A. We're going to obviously add it to the set of numbers that we've seen in A because we've never seen it before. And we're going to say, okay, now we're seeing this number for the very first time, right? So if it's the case that we've seen it in B before, we want to make sure that we increment the total numbers that A and B have in common by 1, right? The reason being that we just are seeing a new number inside of A for the very first time that happens to be in B, so increment the number of numbers that they have in common, right? If it's not the very first time that you see a number, then it must mean that, like, you know, you've already accounted for that, or that you will account for it in the reverse way, right? Whichever, it depends on the order of whether it's seen first in A or B, right? It'll be whichever one sees it later on, right? So it's like, you know, A sees 1 first, and then B eventually sees 1, where you will augment that value plus or equal to 1, right? But that way, if we've seen 1 and so on, we've already accounted for that, and if we see a 1 again in B, we don't want to again increment 1 because we've already accounted for the fact that they have a sharing number 1, right? So if you're adding a number A into the set of A in terms of numbers you've seen in A, it's the very first time you add it, so it's not in our set A yet. We're going to augment cur count by 1 if and only if A happens to also be in the numbers we've seen inside of B so far, which is going to be set B, right? So this will return true if it's in set B, or otherwise false, so it'll increment by 1 if it's true, or by 0 if it's false. I'm kind of abusing Python notation here, and obviously adding it to the number of numbers that we've seen inside of our set A. And here we're going to do the same thing for the little number B here. We're going to augment cur count by 1 if it's already in set A, because that means it's like, oh, this is a new number that they share together, so let's make sure to augment cur count by 1, and then obviously add into the numbers that we've seen in B, right? And we're going to do this for every single index. Here I'm just using zip because it's like I realized that, okay, this is exactly what I need to do here, but the same thing is like going for every single index I, and then A is equal to A of I, and B is equal to B of I, and there you go. And then obviously every single time we're going to append the current count of numbers that they share together into our resulting array, and at the very end we just return the result array, and there we go, bada bing bada boom, a very nice and efficient, crispy solution. The very first time that I did this was just with set intersection, because it was just like, obviously it's just like, okay, this is a do this problem, here's a very easy way to do this, and so on. And then I thought a little harder in terms of how to do it efficient, and just came across this solution at the end of the day, and there we go. And so hopefully that solution makes sense. And yeah, but otherwise, that's pretty much it for this video. If you did find it useful or enjoyable in any way, shape, or form, I would highly appreciate if you left a like or a comment. But otherwise, I'll catch you in the next one. So till then, ciao, ciao, my friend. Bye-bye.